Hello students, how are you? Alright, so in the last session we had done magnetic field due to straight current, right? And we were doing, the derivation we have already done. Now we will be doing few important questions, right? So in today's session, we'll quickly do the important questions, okay? So this, let us recall the basic formula for magnetic field due to straight conductor. B equals mu naught I by 4 pi A into sine alpha, sine phi 1, okay, sine phi 2, right? This is the magnetic field formula for straight conductor, straight current, magnetic field due to straight current, okay? So this was the formula we did in the last session, okay? Now let us read this question. We'll be doing this, okay? Too long, when long parallel conductors are there, long parallel conductors, right? Yes, obviously current carrying conductors. So one is this, when you are saying long, what is the magnetic field due to this current at this point? Let's call this A. So in this scenario, alpha 1, sorry, we had taken phi 1, okay? So phi 1 equals phi 2 equals 90 degree. In that scenario, B is going to be mu naught I by 4 pi A. Mu naught 4 pi A plus into 1 plus 1, right? So this is going to be mu naught I by 2 pi A. So this is magnetic field due to long conductor, right? Long conductor, long means infinitely long. So this is one conductor carrying I1. This is another conductor carrying I2. The distance here is 5 meters. This is given, right? 5 meters in one. Here I2 is 5 ampere and I1 is given 2.5 ampere. 2.5 ampere. Okay, this is given. So current is in the same direction, that you can figure it out. Okay, what they are asking, magnetic field at a point halfway between the wires. Magnetic field at a point halfway between the wires. That means you will have to find out the magnetic field at this point. Magnetic field at this point. Okay. So due to this first conductor, magnetic field will be into the page. That is, if current is flowing in this direction with right hand thumb rule, we will find out the magnetic field due to this conductor, this current into the page, right? So what will be this? Into the page. So this will be into the page. This is B1. All right. Now due to this current, now if current is flowing in this direction, at this point we have to find out magnetic field, so it will be out of the page. So B2 would be out of the page, okay? So this is what we need to understand, because direction is very much important here, so we have to take into account that thing. Okay, here we need to find out the net magnetic field. So magnetic field due to this first conductor and magnetic field due to this second conductor. So you are aware of this fact that magnetic field is a vector, so net magnetic field will be the vector sum of the two magnetic fields. Alright, so let us do this. This is going to be very, very simple. Okay, so let us do this. Magnetic field due to this and due to this. I1, this is 2.5 ampere. I2, this is 5 ampere. Right? This is 5 ampere. So this is there, this is I2, all right. Now this is the point where we need to find out. So if this point is P, mark it. So B1 would be One thing, this is 2.5 meter. This is 2.5 meter. Halfway is 2.5 meter. Why? Because we had this 5 meters. These two wires were separated. These two conductors were separated 5 meter apart. Right? This is given. Distance between them is 5 meter. So this was there. Now, halfway means 2.5 meter. This is 2.5 meter. Okay. This is 2.5 meter. So, what we will do, B1, magnetic field due to this first conductor, mu naught I1 by 2 pi A. Alright, let us put the values. This is very simple. Okay, one thing. Second thing that we need to keep in mind is, as I have told you, magnetic field due to this conductor is into the page. So, this will be in the negative z-axis. Along the negative z-axis. If we consider this is x-axis, this is y-axis, and this will be z-axis, right? Positive outward will be positive, outward will be positive z-axis, inward would be negative z-axis. This is what we have taken. Okay, so mu naught by 2 pi into what? I1 is 2.5. I1 is 2.5. I1 is 2.5 divided by 2.5. So this is going to be there. So ultimately we are going to get mu naught by 2 pi. Alright. Mu naught by 2 pi minus. This is minus. This is k cap. So this is B1. Okay. So this we have already found. What? B1. Magnetic field due to this first conductor we have found. Now magnetic field due to this second conductor. What you will get? This will be mu naught I2 by 2 pi A. Again A is 2.5 only, because this distance is also 2.5. So this we will be putting. So this is going to be okay. And one more thing, that magnetic field due to this current is outward, right? Magnetic field due to this current is outward. So this will be k cap, positive k cap, right? In the positive z-axis. So this would be mu naught by 2 pi into what? 5 by 2.5. This is k cap. That means B2 is going to be B2 equals mu naught by 2 mu naught by 4 pi. 2 mu naught by 2 pi, right? And this is k cap. 2 mu naught by 2 pi k cap, right? So net magnetic field will be what? B1 plus B2. Okay, so this is twice of mu naught by 2 pi minus yes, this is k cap, and it's minus mu naught by 2 pi k cap. This is written in this manner. What I have done, I have just added this B1 and this B2. I have just added. So what we are going to get? We are simply going to get mu naught by 2 pi, right? This is our final result. This is our final result. Okay, so in this, which one? Mu naught by 2 pi. This is the result, right? So this was so simple. We have to look into this, that if magnetic field we are supposed to find out for long straight conductor, magnetic field is going to be mu naught I by 2 pi A. A being the distance. A being the distance from the conductor, right? From the conductor at the point where actually we are finding out the magnetic field, right? Okay, so this we have done. Now let us move to the other question. Okay, this is the question. This is the question. Okay, so in this, just figure it out, just this one. You have taken that this two semicircular stuff is there. Two semicircular wire is there. Okay. You may ask that, okay, this segment is also there. Due to this segment, magnetic field at this center would be 0. Why so? You are aware of this fact. If we have what? We have dB equals mu naught I dl sine 0 degree upon this 4 pi r square So this is going to be 0. You are aware of this. If sine 0 is 0, if there is sine 0, what is angle? Angle between ideal and R. If angle between ideal and R is 0, then dB equals 0. This we need to keep in mind. So these two segments will have no magnetic field, right, at this point. Okay, so only these two semicircular stuff, these two semicircular arc will give us the magnetic field, this one and this one, right? Okay, so let us talk about this. Magnetic field, okay, this is what? Clockwise. And this is what? This is clockwise. And what about this? This is clockwise, this is also clockwise. Oh my God. This is clockwise, this is also clockwise. So, if you consider this, due to this one, into the page, due to this one also, due to this one also, into the page. So, for both the semicircular segment of the wire, magnetic field here would be into the page. So, let us do this. Let us do this. So magnetic field B1 equals, let's call this one B and this as 2. These two will have no effect. So due to this, what will be there? Mu naught I by 4R1, and this is minus K cap. Okay, B2 equals mu naught I by 4R2. This is also minus K cap into the page, right? Just add them up. Simply, we need to add them up, right? So B equals, magnetic field equals B1 plus B2. Just do this. This is very simple, no? R1 by R1, mu naught I by 4 into 1 by, and this is minus K cap. So if you don't consider the, if you don't consider the directions, so you may drop this negative sign. Okay, this is R1 plus R2, both will be added up. So this is going to be the final result. If you will work it out, your answer is this. Okay, this is your answer. So this is done. Let's do the next question. Okay, so have a look. This is very simple question. This is the segment. This is the segment. If you remember, B equals mu naught I by 4 pi R into alpha. Alpha is the angle made by arc. Angle made by arc. Right? So, alpha is measured in, if this is not there, this angle is what? This angle is alpha. So what is this angle? 3 pi by what? 2. Yes, of course, pi by 2 plus pi by 2 plus pi by 2, 3 pi by 2. Okay, so this we will be putting. So B equals mu naught I by 4 pi R into 3 pi by 2. 3 pi by 2. And what about the direction of magnetic field? It is upward. Why? Because this is anti-clockwise direction. Current is flowing in the anti-clockwise direction. When current is flowing in the anti-clockwise direction, magnetic field will be outward, right? So this is our final result. So what's the result? B equals mu naught 3I, right? 3 by, this will be 8R. So this is our result, okay? So this is final result. This is what we have done. So this was the basic questions based on BS law. Let us do few more questions, okay? Let us do few more questions. Suppose you have this question number . Question number 4. Okay. So let us do this. This is going to be very, very simple. We have long straight conductor. Okay. We have another long straight conductor. Right? And this has been, this has been connected to the semicircular arc. Some semicircular arc. Okay. So this is going to be this sort of stuff. Now this is the center. This is the center of this semicircle, right? And current is flowing in this manner. Current is flowing in this manner. So we are aware of this. Okay, this is radius, and this is also R, right? Okay. So there are 3 segments. How many segments? There are 3 segments. Segment 1, segment 2, segment 3. And we need to add them all. Okay, so let us do this. Current flowing is I. In this entire loop, the current flowing is I. So B1, let's do this. B1 equals what? B1, what is B1? What is B1? B1 equals, for this one, mu naught I by 4 pi R. Okay, mind it that this is semi-infinite. One end is here, another end is infinitely away, right? So this is semi-infinite, and due to this semi-infinite straight conductor, magnetic field is this, mu naught I by 4 pi R, mu naught I by 4 pi R, and then what is the direction? Yes, direction. Current is flowing in this direction, and due to this here outward, right? At this point, due to this, if current is here, if current is flowing in this direction, magnetic field is outward. So outward here. Okay, so this is positive K cap. This is B1. Now B2, this segment, due to this semicircle, mu naught I by 4 R. All right, mu naught I by 4 R. Okay, this is the direction. This is what? Anti-clockwise direction. This is anti-clockwise direction. Again, this is outward. Right? Now B3. B3 will be mu naught I by 4 pi R. This is magnetic, right? This is straight current, semi-infinite straight current. So magnetic field at this point P will be outward, right? Here current is flowing in this direction, and here we need to find out magnetic field. This is outward. So this will again be along positive z-axis. So now what we will be doing, we will add them all. We will add them all. B1 plus B2 plus B3. Okay, if we will do that, see what is coming up. Mu naught I by 4R we can take common. Okay, because this is for, you know, in all the three segments, right? So magnetic field will be mu naught I by 4R into this is 1 by pi. Okay, 1 by pi. This is 1 for this one, right? Plus this is again 1 by pi. So what is the answer? What is the answer? Just add them all. Okay, so this is going to be the answer. This, you know, in the opposite, along the positive z-axis, right? Along the positive z-axis. So this is our basic, structure. Now let us do another, because we need to, we need to do the multiple questions based on this. Do this one. Now we will be talking about magnetic field due to square loop. Magnetic field due to square loop. magnetic field due to square loop. Okay. So we have this. Just be very careful while doing this. Okay. This is the square loop. Let us do this as, okay, current is flowing in this direction. Take this. Yeah, why not? We can do in this manner. Okay, now suppose this is the point where we need to find out the magnetic field. Okay, this is the point. Let's call this point 3, segment 4. Right. So magnetic field due to this one outward. Why? Magnetic field, if current is flowing in this direction, magnetic field is outward. Okay. For this, it is again outward. For this, it is again outward. For this, look at this. It is again outward here. Right? So for all the currents, magnetic field at this point P would be outward. Right? Okay. So do this. We need to work out, in this manner. First of all, we have to figure out what is the perpendicular distance. Okay, this is the perpendicular distance. If we have taken the square of side A, we will be given the square of side A. Then what? Then this distance will be A by 2. This distance will be A by 2. A by 2. A by 2 distance will be from here to here. Okay. That means the perpendicular distance from the point to the wire to the conductor will be A by 2. So let us put this here. Alright. Now, and this end are making some angle. Right? This angle and this angle. It is quite easy that these two angles will be 45 degree, right? These two angles will be 45 degree. So this will be 45 degree. Okay, this will be also 45 degree. So due to this one conductor, what will be the magnetic field? So let us do this. B equals 4 into B1. Why so? Because all the segments have magnetic field in the same directions. So what we will do, we will add up all the magnetic fields. Right? So simply we will be doing this. B equals 4 times mu naught I by 4 pi, and this is A by 2. Why so? This is the distance. This is the perpendicular distance. Now what we will do? We have sine of 45 degree. So sine 45 degree equals what? 1 by root 2 plus 1 by root 2. Okay. This is what we are going to do. So B equals mu naught. This will go up, right? 2 mu naught I by 4 pi. Okay. This will be root 2 here. This is 2. Okay, so what you will get? B equals finally mu naught I by root 2 pi. Yes, we can do this. This is the magnetic field due to the square loop at the center. Right? What we had done, we had simply used this formula. B equals mu naught I by 4 pi A into sine phi 1 plus sine phi 2, right? Sine phi 2. So phi 1 and phi 2 both are, phi 1 equals 45 degree, phi 2 equals 45 degree. So sine 45 is 1 by root 2. That's what I have put here, right? This is the easy one. Okay, in the next session we will be doing Ampere circuital law. One thing. Second thing, you will be getting the test and assignment also. So keep doing whatever we have done till now. Practice properly.